Hello everyone, my name is Utkarsh Nagdar. In today's session, we are just going to study about motion of block connected by a massless string. We have to focus on 2 to 3 terms. That first thing is that we are talking about motion, and whenever we are just going to discuss about the motion, it should be clear that somehow an unbalanced force is acting on it. We have discussed all those stuffs in the previous lectures, that balanced force is responsible for distortion of shape. It should be clear to you. And whenever we are talking about unbalanced force, so basically unbalanced force is responsible for motion of any body. Okay? And even we have discussed that what actually this motion represents and how we can analyze that a body is in motion. So basically what I have focused in previous lectures, that motion is all about velocity. So if there is change in velocity, then we can say that motion is being changed. If velocity is constant, then we can conclude that motion is constant. It should be clear to you. This is very specific term what I just want to focus. Now let us move forward and discuss about motion of block connected through a string. Exactly. So what we are discussing about motion. So could you please tell me whether the force applied here will be balanced or unbalanced? Exactly, gentlemen, force will be unbalanced. Why? Because we are talking about motion, and whenever there is motion, there must be an unbalanced force acting on a particular body. Let us move forward and discuss this particular case. Although I would just like to tell you, this is one of the most favorite topic of competitive examination like JEE mains and NEET. Okay, now we can see in the figure number first, I am discussing about these two cases through which this is our massless string in which tension T is generated. Okay, this is our massless string in which tension T1 and T2 is generated. Force F is applied on the body and they are connected like this. Now let us move forward, and I am just going to discuss about this body number A, whose mass is m1. Could you please tell me what will be the free body diagram of this particular body will look like? You will say, sir, free body diagram is a diagram in which we are simply representing all the applied force on that particular body. But gentlemen, there is one force we are just going to ignore in this particular free body diagram, that is motion, that is, sorry for my words, that is gravitational force. Why I am just going to ignore that particular gravitational force? Reason for that is we are not computing any kind of motion in vertical direction. We are just going to discuss about the motion in horizontal direction. That's why we are not going to discuss about the horizontal force. Okay, so what will be the tension applied? You will say, sir, tension. Okay, now tension. So basically I would just like to give a trick to you that we have to remove tension in our life, so you can do something like this. Tension ko dur rakho always. So this will be the body, this will be the body number m1. So could you please tell me where will be the tension force applied through this particular string? So what you will say, tension will always be working on away from the body, और ये हमेशा क्या रहेगी, दूर रहेगी. So tension will be in this direction. This will be the required FBD for body A of mass m1. Now I am talking about body B of mass m2. Could you please help me with this? What will be the force applied? You will say, sir, force F will be applied in right direction. Where will be the tension force applied? You will say, sir, tension T will be applied in left direction. Why? Because we have to consider tension always away from the body. Is it clear to you? It should be clear to you. This is very important. Although we have discussed all this stuff in previous series. So now let us move forward. We have to create equation of what? We have to equate force. How we can equate the force? Forces can be equated by considering that particular motion and by considering the effect generated by that particular force. What is the effect in this particular case generated? As it is unbalanced force, so the effect will be motion. Exactly. And that particular motion will be represented in form of acceleration. If there is some force is applied on a particular body, and so there must be acceleration on that particular body. Okay. So as this body is connected through massless string, we can consider that this particular system is moving with acceleration A. Can we consider this? Exactly. So when we are talking about system, it simply means that body N2 is moving with acceleration A, body N1 is always also moving with acceleration A. Moving forward, now could you please tell me what is effect of this particular tension on this particular body? So you will say, sir, tension is a force which is accelerating body of mass m1 with acceleration A. This is what? Reason for this motion. This is what? Reason for this motion. This is how we are just going to equate this force. Is it done? It should be clear to you. Now, let us move forward, and could you please tell me what is the magnitude of that unbalanced force which is applied on body B of mass m2? So F minus T, exactly gentlemen, we have discussed all those things. F minus T will be responsible for generating acceleration on the body of mass m2. Very good. This will be what? This will be our required acceleration. Is it clear to you? Is it clear to you? Okay. Now, could you please tell me that, sir, there will be some kind of, there may be some kind of overall acceleration we can calculate. So basically what this particular force is doing. So you will say, sir, this particular force is accelerating a system of mass m1 plus m2 with acceleration A. So how you can say, on the basis of this, we can simply say that acceleration will be equal to F divided by m1 plus m2. Is it clear to you? Is it clear to you? Okay. So it can be easily calculated by applying the simple formula. Moving forward, and now we have to discuss about tension. What will be the magnitude of tension? What will be the equation for tension? How you can calculate? You will say, sir, it is very easy. We can easily apply concept like this. Okay, so what is the force applied? You will say value or magnitude of that particular force will be equal to what? m1 plus m2. m1 plus m2 multiplied by A, isn't it? Okay. Minus tension T will be equal to what? m2 A. So what will be the value of this tension? This will be nothing but equal to m1 plus m2 multiplied by A minus m2A. This is how we can calculate the value of tension. So this is how we can easily calculate value of tension if acceleration is given. What if we are not having the magnitude of acceleration? You will say, sir, we can easily calculate the magnitude of acceleration by applying the simple formula. What if I am just giving you the value of force? Okay, so we can put acceleration is equal to what? We can put acceleration is equal to m1 plus m2. What we have calculated? F divided by m1 plus m2. Exactly, can be calculated like that. Minus m2 multiplied by acceleration is equal to, could you please tell me that? F divided by m1 plus m2. Exactly. So simply it can be calculated something like this. This will be equal to F minus m2 multiplied by F divided by m1 plus m2. So this is how we can easily calculate all those formulas. Let us move forward and discuss about case number second. So could I remove this? Okay. Now let us discuss about case number second. Okay, so now we have to discuss about case number second by, first of all, by going through the free body diagram of this particular case. So how many bodies are there? You will say there are three bodies. Body number m1, body number m2, and third one is m3. Exactly. So we are just going to consider the horizontal action of force. We are not going to consider vertical force. It should be quite clear to you. So m1, force applied in body m1, that will be tension force T1. We are just going to consider tension always away from the body. Tension को हमेशा ही दूर रखना है. Exactly. So in the body number m2, T1 will be applied away from the body. Exactly. And T2 will also be applied away from the body. Exactly. Force F will be applied on right hand side, exactly, and T2 will be applied away from the body. This will be what? This will be our free body diagram. Could you please tell me the equation of all three bodies? Exactly, if we are considering that particular system is moving with acceleration a due to this particular force F, then let us start M1. So T1 force, you will say something like this: T1 force is responsible in generating acceleration on body A of mass M1. Acceleration A of body of mass M1, exactly. Now T2 force, we are going to discuss about this system. So T2 minus T1, that means this set of unbalanced force is responsible for generating acceleration A on body of mass M2. Now moving forward, F minus T2 force will be responsible for generating acceleration A on body of mass M3. So this will be three equations for these three bodies. Now let us discuss about tension and acceleration in this particular case. In this particular case, we are just going to discuss about tension and acceleration in this particular case. Okay, so now could you please tell me that what will be the net value of acceleration? So you will be saying that force is equal to total mass multiplied by acceleration. So force will be equal to, what is total mass? You will say m1 plus m2 plus m3 multiplied by acceleration. Exactly, Bacho. So acceleration will be equal to nothing but f divided by m1 plus m2 plus m3, isn't it? Exactly. So it will be something like that. Acceleration is equal to force divided by m1 plus m2 plus m3. Okay. Now, if we have to calculate the magnitude of T1, I am just going to calculate the magnitude of T1. Then we will conclude this lecture. This will be a homework. Okay. So T1 will be equal to what? M1 multiplied by f divided by m1 plus m2 plus m3, isn't it? Exactly. It will be something like that only. Okay, now can you calculate the magnitude of T2? So yes, we can calculate the magnitude of T2. How we can calculate the magnitude of T2? By simply putting the value of T1 by this particular equation. So it will be something m1 multiplied by f divided by m1 plus m2 plus m3, isn't it? Okay, so this will be equal to m2 multiplied by, what we have to multiply, the value of acceleration, and that particular value of acceleration is equal to f divided by m1 plus m2 plus m3. Can you calculate this? Yes, we can simply calculate this value by doing simple algebraic operation. That means we have to transfer this particular value over there. So it can be done something like that tension T2 will be equal to m1 multiplied by f whole divided by m1 plus m2 plus m3 plus m2 multiplied by f whole divided by m1 plus m2 plus m3. Exactly. So what we can take common over here, we can simply see that f divided by m1 plus m2 plus m3 can be considered as common in this particular case, and remaining value will be equal to m1 plus m2. This is how we can simply calculate the value in this particular case also. This is how we can simply calculate tension, acceleration in a case of block connected